11.2, we're going to look at evaluating limits. First of all, we have what we call dividing out techniques, and this would only be applied, we only use this technique right here if for some reason we would happen to get, by substituting, you get 0 over 0. Now, dividing out techniques is simply, factoring and reducing. That's what that is. All right, we would only need to do this if we do, again, get 0 over 0, or we have some problem because of the division of 0. Interdeterminate form. Again, this interdeterminate form is when the fraction yields this 0 over 0. If the direct substitution produces the interdeterminate form in a rational function, you can conclude that it has no meaning as a result or as a real number, and it is not possible to determine the limit in that form. And since we can't determine the limit in this form, then there are things that we will do so that we can determine the limit. And so the next 3 examples here are going to follow this format. First example. So you can see here that if I put 3 in, what's going to happen here is first of all, I'm going to get division of 0, which I can't have. But also, if I put 3 in, see I've got 9 on top minus 24 plus 15. So we end up getting 0 over 0, okay, if I do a direct substitution. So with that being said, what I need to do is rewrite my limit as x approaches 3 and factor. So I'm going to factor the top here into the 2 binomials, and they would be x, let's see, this would be minus 5 and an x minus 3, and we still have it over x minus 3. So this allows us to simplify, crossing out my x minus 3's. So we are taking the limit as x approaches 3 of x minus 5. This concludes that my answer then is 3 minus 5. You substitute. So the answer is negative 2. The answer to the limit is negative 2. All right, in this next example here, again, if I put 3 in, I'm going to get 9 minus 9, so that's 0 over 3 minus 3, which is 0. So what we have to do is, rewrite the limit. So the limit as x approaches 3 of, and on top it's x plus 3, on bottom, and also x minus 3. On bottom it is x minus 3. So we can cross out our x minus 3's. So the result of the limit is 6. All right, let's look at one more example here. The limit as x approaches 1 of x minus 1 over x to the third minus 1. Well, again, this gives us 0 over 0. So we are going to write the limit as x approaches 1. On top, we have x minus 1. And on bottom, I need a factor. Well, to factor this difference of cubes, it is the cube root of each one of those, x minus 1. And then we square the first, x squared. This is a factoring pattern. We would have first been introduced to it in Algebra 2, plus x, and plus 1. All right, so I can go ahead and cross these out. And this is the limit as x approaches 1 of 1 over x squared plus x plus 1. So the result of this limit, if I put 1 in, is going to be 1 over 1 plus 1 plus 1, so 3. So the answer to this limit is equal to 3. All right, so that again happens when we are given the interdeterminate form of 0 over 0. So we need to figure out algebraically how to simplify some of those. The next technique that we have is called rationalizing, when we have to do the rationalization to get rid of square roots and so forth. To rationalize, what we will do is we're going to multiply by a form of 1 and using the conjugate. Just a quick example of what that would look like if I have 1 over 1 minus the square root of 3. See, what I would typically do in the past is I would multiply by 1 plus the root of 3 on top and bottom. This is the conjugate, and this is an expression that is equivalent to 1 right there. So that's what the rationalizing is going to look like. Let's look at this example 4. We can see here that I've got this square root with this situation here. I can't divide by 0. And what happens is if I substitute here, direct substitution, I get the square root of 1 minus 1 over 0. Well, this is still equal to 0 over 0. So I need to do some rationalizing in order to get it to a different form. So I'm going to take my expression, the square root of x plus 1, minus 1 over x, and I'm going to multiply it by the conjugate. Well, the conjugate comes from what the expression is from the top. Most of the time it's always from the bottom. So my conjugate would be multiplying by the square root of x plus 1 over the square root of x plus 1 plus 1. And so what we need to do here is multiply all of this out. My result would be, if I multiply the top here, I'd get the square root of x plus 1 times itself is x plus 1. And the square root of x plus 1 times 1 is plus the square root of x plus 1. And then this negative 1 times the square root of x plus 1 is minus. I'm just foiling right now. And then negative 1 times positive 1 is minus 1. So there's my top. On bottom, I have x times the square root of x plus 1 and plus x. I'm going to go ahead and do some simplifying here. And the simplifying is going to be, let's see, on top, I'm going to cross out my square root of x plus 1s and the negative 1. So I'm left with x over x square root of x plus 1 plus x. Well, you can see here that, maybe I didn't need to necessarily distribute that x in the denominator because I've got an x on top, and I can take that x back out on bottom. And what we have here is we can cross out the x's now. So cross those out, cross that out, and we're left with 1 over the square root of x plus 1 plus 1. All right, so now what we're going to do is we're going to evaluate the limit. So here's what this would look like. So what is the limit as x approaches 0 of 1 over the square root of x plus 1 and then plus 1 on the outside? So now we're substituting 0 in. If I put 0 in on bottom, so I've got 1 over the square root of 1, which is 1. 1 plus 1 is 2. So if I evaluate this, so the result of this limit is equal to a half. All right, let's look at one more of these. So the conjugate, let's just jump right in and do this conjugate thing. So I need to multiply top and bottom by the square root of x plus 2 minus the square root of 2 over, or plus the square root of x plus 2 plus the root of 2. Here's what we're going to get. The square root of x plus 2 times itself is x plus 2. The square root of x plus 2 times the root of 2, and then the negative root 2 times the square root of x plus 2. Of course, those are going to cancel out, so I don't need to worry about those. That's the middle terms that actually give us a sum of 0. And then negative root 2 times positive root 2 is minus the root 4, which is minus 2 over, I'm not going to distribute this time. X times the square root of x plus 2 and plus the root of 2. So what we're looking at here, see the 2's are going to cancel. I'll go ahead and do some simplifying here for you. The 2's are going to cancel. The x would also cancel top and bottom. So we are looking at finding the limit as x approaches 0. We've got 1 on top over the square root of x plus 2 plus the root 2. So let's put 0 in. And if I substitute 0 in, I'm going to get 1 over the root 2 plus the root 2, which equals 1 over 2 roots of 2. I'm going to keep going. I'm going to multiply top and bottom by the root 2. So it's the root 2 over 4. So this is the result of the limit. So that's kind of some basic rules here that we use for evaluating limits. I'm going to go ahead and end this video. In the next video, we'll look at limits with the graphing calculator and limits from one side.